Now in this problem we're going to use 4 different methods to calculate the price of the bond. And then because we're given the semi-annual rate, so I'm going to treat this as 4.2%, treat this as 5%, and then I'm going to treat it as like a 20-period bond. So the unit doesn't really matter, it could be year, it could be months, so as long as the units all align, so this is like a 20-period bond with 20 periods, and these are the interest rates of that period of time. So this 4.2% will be the coupon rate for 6 months, and then we'll have 20 periods of 6 months, and then this will be a 5% yield for 6 months. So as long as the units align, we can always use the formulas. So first of all, let us determine what our inputs are. So when we calculate the value of a bond, we have a lot of inputs. So the first input is the number of periods. So of course it's equal to 20, and the yield rate is equal to 5%, and the coupon rate is equal to 4.2%, and then we also have a face value of 1,000, and then we have a redemption value of 1,050, and of course we have the special rate G, which is defined as CG equal to FR, so G is equal to FR over C, and in our case this is equal to 1,000 times 0.042 divided by 1050. So this is a special rate that comes in handy later on. And also we need to define G, the base rate. So the base rate is defined by GI is equal to FR. So all we have to do is take FR divided by I. And in our case, F is equal to 1,000, the face value. The coupon rate is 4.2%, and the yield is equal to 0.05. So these are all our inputs. So all these numbers will come in handy later on. So let's move on to method 1, which is the basic formula. So for the basic formula, once again remind ourselves it's equal to this. So this is all very straightforward. So you're just taking what you receive at whatever time you're receiving it, and then just bringing it back to time 0. So in our case, this is simple enough. So FR, the face value, is equal to 1,000 times 4.2%, that's just 42. And then it's at 20 years at 5%. And the redemption value is 1,050 v to the power of 20. So all you have to do now is just to substitute this formula in, which gives us 919.147. So this is the answer. So moving on to the second method. So method 2, we're going to have to use the premium discount formula. And the premium discount formula tells us that the price of the bond is equal to the redemption value plus the redemption value times G minus I A N I. And then just to remind you how to prove this, so if you're trying to prove one of these formulas, always start with the basic formula. So this is, the basic formula is pretty much the definition of everything. So for FR, I'm going to change this to CG. And then for this term over here, I'm going to minus 1 and then plus 1. So I'm going to have a plus C on the outside. So here ANI, and then this looks something that so this looks suspiciously like a ANI, right? So this kind of looks like what you have in the annuity immediate. So all I have to do is just to minus, take the minus sign out, so I get 1 minus v to the power of n, and then divide this by I, and then I multiply it by I on the outside. So this is actually ANI, so I can replace this term inside the brackets by ANI. And then once this is replaced, I can simply just group everything out of the bracket, and then plus C. So there you have it. This is how you prove the premium discount formula. So now we're going to apply this formula to calculate the price of a bond. So let me just write it out one more time. So for the price of a bond, we just substitute our numbers in. So our redemption value is 1,050. And then G, as we found before, is equal to 1,000 times 0.042 divided by 1050. So it's just FR, the redemption, the face value times the coupon rate. So this is the amount of amount of interest that you receive per period, divided by the redemption value. And then in our case, the I is equal to 5%. times A 25%. So once again, this is just a matter of substitution. You just put it in your calculator, and then you should get the same answer, 919.147. Now moving on to the third method. So the third method is the base formula. Now, this is actually less commonly used, but it's still a good thing to know about. So once again, let's try to prove this formula first. So as always, we start off with the basic formula. So let's try to substitute G into the formula. So recall that Gi is equal to Fr. So all we have to do is just to get rid of the Fr. And then obviously there's an I that can cancel out with the denominator in the annuity immediate term. And so this gives us G plus C minus G v to the power of n. So that's how you do this. So that's how you prove the base formula. So now let's just apply it directly. So once again, let me just copy this out. So substituting our numbers in, G is equal to 1000 times 0.042 divided by 0.05. So once again, it's the face value times the coupon rate divided by the interest rate, by the yield. And then C is 1050. And then G is just equal to this. I'm not going to write it out again. So you get the point. And then it's 20 periods, so v to the power of 20. So this is going to be equal to 919.147. So this is how you use the base formula. So for the last formula, we're going to use Maykamp's formula. And Maykamp's formula is equal to K plus G over I C minus K. K is the present value of the redemption value. So all we have to do now is just to substitute everything into this formula. And once again, let's try to prove this formula. See, v to the power of n. So immediately we can replace this as k. That's what the definition of k is. So k is really just the present value of the redemption value. And then for fr, we're going to replace that by cg. So plus k. And then here we can expand the formula for the annuity immediate. And immediately you can see that if we multiply the c inside, we have c minus z to the power c times v to the power of n, and that's just equal to k, right? And so there you have it. That's how you prove Maykamp's formula. So now let's just apply this formula directly. So k plus g over I c minus k. So k is the redemption value, and bring it back to the present. So it's just a present value. And then g, as you know, we've used this several times before. I'm not going to write it out again. So as always, just remember Cg is equal to Fr. So G is also equal to the redemption, the face value times the coupon rate divided by the redemption value. So you can just substitute that in, and then once you do your calculations, this should be equal to the same value that we found before. So that's how you apply the 4 different formulas.